Okay, let's do this addition. So this would be like a 5-mark kind of thing, 1 mark for the answer, 1 mark for N, Z, V, and C. So let's see how this works. So 13, this is 13 plus 11 is 24, which is 16 plus 8. 10 plus 1 is 11, plus 12 is 23, so I believe that's 78. Well, N is the most significant bit of our 8-bit result. Our 8-bit result is 0, 1, 1, 1, 1, 0, 0, 0, so this is our N bit. So if we thought of this as a signed number, this number would not be negative, not negative. Now we also see here we have a carry, or in our case it is carry because we're adding. And let's take a look at what kind of numbers we have here. This is a negative plus a negative, and strangely enough it gave us a positive, so our B bit would indeed be 1. Now here's the thing, for Z, so this is the MSB of a result, this is the carry, which in our case says unsigned overflow, signed overflow. This result is not valid in either number system. Is this number 78? Is it 0, 0? And our answer is not 0. Is that if you take FF and subtract a number, that's called its ones complement. Because if you look at the original binary we did, if you invert numbers, a 1 is a 0 is a 1, you add those two numbers together, you're always going to get FF. So FF minus a number in hex is always the ones complement. How do you get the 2's complement? You add 1, and that becomes a 2's complement, or the negative of this value. Well, here's the deal. Adding and subtracting can be done equal operations. So FF minus a number plus 1 can be rewritten as FF plus 1 minus the number. Now, if you do this, what does that mean? FF plus 1 is really 0. Subtract the number. So what we're going to get here is the 2's complement of AB, which is a negative of AB. So again, the lazy Joe over here and hardworking Bob. So Bob's going to take out the loan. He's got 16. He gives 1 of that to the lazy Joe here. So he's got 16 minus 11 is 5. So we've got 55. Now if you add these two, you will get 0. So here's the thing. If I take AB plus 55 and Z, V, and C for this guy. Okay, so 11 plus 5 is 16, which is 1, 0, 1, 0. And what do we have? The most significant bit of the 0 is a 0, which is not negative. What about our carry? We had a carry. This is a negative plus a positive, so we do not have a sign overflow. And this, yay, this is a 0. Only when you hit 0 is this 1, saying, yes, I got 0, I'm special. So you should be able to figure out the NZVCs for all of these, and as before, if you have to convert the binary to hex to do it and convert back, then the most significant bit is the N bit. If it's 0, it's a 1, otherwise, all other 255 numbers, it's not 0, only 0 is 0, not a signed overflow, and yes, a unsigned overflow. You can get a signed overflow if you add a positive plus a positive and get a negative. V is 1. If you add a negative plus a negative and get a positive, V is 1. However, if you add a positive plus a negative or a negative plus a positive, V is 0. Also, if you happen to do the normal stuff and say I've added a positive plus a positive and I got a positive, V is 0. If I add a negative and get a negative, V is 0, because that's what you expect. When you get something you don't expect, V is 1, which is our signed overflow. So if I say 5 subtract 3, that's the same thing as 5 subtract positive 3, or 5 plus negative 3. And if you understand this concept here, we can convert a subtraction into a 2's complement addition. Because what does the 2's complement do? The 2's complement gives you the negative of this. So negative 3 and 3, that's the 2's complement. Let's do 3a minus 9c. Borrow 1, c is bigger than a, borrow 1 from the 3, make it a 2, that's a 1a, which is 26 minus 12, which is 14, which is e. or 1 from the carry, that's 18 minus 9 is 9. And so we've got a calculation here. So if we look at it, we've got a result. But what we want to do is figure out, is the overflow set by this? The sign overflow. Well, if you look at 3a, that's positive, and you're subtracting a negative. But as we just saw, if you want to convert a subtraction into an addition, you have to add the opposite sign. So if this is a positive subtract a negative, that's the same thing as a positive plus a positive. And in this case, we've got a negative, and therefore b is 1 for this guy. So when you're doing subtractions, you have to rethink. You don't have to do the calculation, but you have to think, what would this be as a 2's complement addition? 3a minus 6f. Let's take a look without even doing the calculations. This is a positive, subtract a positive, right? Which is the same thing as a positive plus the opposite of this, a negative. Adding numbers of opposite sign, v is 0.